Hello and good morning to all of you. I hope all of you are doing well and all of you are in good health. So, in today's class, we will be focusing on a very simple yet important concept in case of object-oriented paradigm that is called as an abstract class. Now, sometimes implementation of all the functions may not be provided in the base class because we may not be capable of determining what would the implementation of the function look like. Now, let us try to understand it with the help of an example. Let us consider a class shape. Now, it may be difficult for us to create definition for a function draw in the class shape itself because shapes may be of different types, and depending upon different types of shape, we need to have implementation for the draw function. So it may be difficult for us to create definition for the function draw in the class shape. But we will definitely have implementation for the function draw in the individual classes that are derived from class shape. Say for an example, if we derive a class circle from class shape, so we'll have implementation of draw function in the class circle. Likewise, if we derive a class square from class shape, then we'll have implementation for a function draw in the class square. So depending upon the different types of shapes that have been derived from the base class shape, we'll have implementation for the draw function. Now, in order to in order to facilitate this, we have a very important concept in case of object-oriented paradigm that is called as pure virtual function. So a pure virtual function is a virtual function in C++ for which we do not have any implementation, but we have only declaration. Right? So a pure virtual function in C++ is a virtual function for which we do not have any implementation, but we only have the declaration. And a pure virtual function is initialized to 0. So just see here, we have a very simple example. So we have a class base where we have the data members and we have member functions. Data member, we have a single data member that is x. We have two member functions, fun and getX. Now fun here is declared as a pure virtual function and the declaration is initialized with 0. So here, based on the requirement of the derived class, we'll have different definitions for function fun. So here we have a class being derived from the base class, and the mode of derivation is public. So integer y, so public. So just see here, we have a definition for fun that is specific to derived class derived. So this is the way how pure virtual function works. So in the main function, we have an object of the derived class, and using the object of the derived class, we have made a reference to function fun that belongs to the derived class. So here it will give me the result fun called. So this is what abstract class is and what virtual function is. So in today's class, we have learned about what is an abstract class, what is the very purpose of the abstract class, right? And we have learned about why we cannot create definition for all the functions inside the class. We have learned about the use of pure virtual function. We have learned about what pure virtual function is assigned with, and we have learned about how to redefine the function in the derived classes. So thank you very much. This brings us to the end of the inheritance chapter. I hope you have enjoyed it. So have a very good day.